In this video, we will give an introduction to Docker. We will see what it is, what kind of problems it solves, what are images and containers, and we will learn how to work with containers. Docker is a platform used by programmers and administrators to develop, run, and deploy applications in containers. I like to think of a container as a small isolated computer which can run a program. This program can be as small as a script that writes "Hello World" in the console, or as large as a web application in ASP.NET Core, NodeJS. It can be a database engine like SQL Server or mysql, or an operating system like Ubuntu. Docker represents a whole set of tools to work with containers and everything related to them, such as images, networks, services, automation scripts, and others. Containers are created from images. An image or image container is a template from which we can create a container. An analogy of software development is to see an image as a class. In a class, we can place methods and properties, but these alone do nothing. We need to instantiate the class to be able to perform actions with the objects. In our case, the images are the classes and the objects are the containers. In an image, we can place what is going to be in a container. We can say, for example, that our image will contain the ASP.NET Core runtime and our ASP.NET Core application. So, when we run the container from the image, we will be able to run our ASP.NET Core application from the container. An image is read-only, that is, it cannot be modified, while a container can be modified. We have already said that containers are what we get when we run an image. If we have an image of Node.js, then the container is going to be an execution environment with Node.js. That is, we could enter our container and interact with Node.js. We could run arbitrary JavaScript code if we wanted to. From the same image, we can instantiate as many containers as we want. Thus, if we have a Go application in an image, we can instantiate that application as many times as we want in different containers. Containers, just like virtual machines, are isolated, so that the container cannot get out of its box, and also nothing can enter the container unless we make the configuration to make this happen. This configuration is important because sometimes we will want to have several containers to communicate with each other. For example, you can have a web application in a container and a database in another container, and you want these containers to communicate with each other. You can configure this by creating a network, which we will see in a future video. We have talked about images containing the runtime of ASP.NET Core, NodeJS, SQL Server, Ubuntu, among other things. Where are these images? Well, we can find them in different places. The most common to use is Docker Hub. In Docker Hub, we can store and download images of different technologies. We can upload our own images there to share with other people. We already have a notion of Docker, images, and containers. Now, let's see what problem containers solve. One of the main advantages of containers is that they allow us to encapsulate in one place what is necessary to run a certain application. This is quite useful, because we ensure that the necessary dependencies are present at the time of software execution, with the precise versions that our software needs. In that sense, anyone who wants to run your application just needs to run a container from the image. Another advantage of this is that, if you wish, you can clean your computer from some software. With Docker, you can run Node applications without having Node installed on your PC. The same with ASP.NET Core and any other technology. And this includes all versions of these softwares. For example, you can have images with every version of .NET. You can have an image for .NET Core 1, .NET Core 1.1, 2.0, all the way to the latest version of .NET. And you don't need to have all these versions on your machine. You can have them on images, and you can create containers from those images. Another advantage is that, given the fact that containers are isolated, this means that we can protect our computer from the application inside a container. Something that makes containers efficient in regard to storage is that different containers can share resources. specifically images or layers of images. The idea is that if you have, for example, two applications that use ASP.NET Core, both in their respective container, it's not like you have to have the ASP.NET Core image twice. No, the images are reused, and since the images are read-only, there is no problem with this, because it is not possible to edit an image. Therefore, your two ASP.NET Core applications share the same image and therefore save storage resources. The way to install Docker varies by operating system. If you have Windows 10 or Mac, you can use Docker Desktop. As you can see, we have Docker Desktop here and you can download it by pressing this button. In the case of Windows 10, it must be the professional or enterprise version of Windows 10. If you have Windows 10 Home, you can run these scripts that I found in Reddit, which will at least allow you to install Docker Desktop on Windows 10 Home Edition. There are also instructions to install Docker on Linux. In my case, I will use Windows 10. After installing and running Docker Desktop, you should get a whale icon in your tray icons in Windows. If we open PowerShell and type the command docker version, we will check if we have installed Docker correctly. And here, as you can see, we have the version of Docker that I got on my machine. And here we have client and server. And as you can see in server, I have Linux, which means that I am going to run Linux containers. Though, if you want, you can run containers on Windows. Now, let's run our first container. We know that we need an image for that. We can use a command to run an image, and if Docker does not find that image in our PC, it is going to go to Docker Hub to find it, download it, and run it, hence creating the container. The command that we're going to use is called run. So we're going to say docker run, and then we put the name of the image, which is going to be, in our case, hello world. And I am going to press enter, and because I don't have that image on my PC, currently it says unable to find image locally. So then what Docker does is to try to pull the image from Docker Hub in my case. And then after it downloads the image, it runs the container from the image. And in this case, because this is just a hello world example, what this container does is to write this message on the console. Now that we have downloaded the image, that image is located in my PC. So if I say docker run hello world again, I'll press enter, and as you can see, it does not say unable to find image. As you can see, we have docker run hello world, and then we have the message hello world from Docker, which is the message that the container writes in the console. Not quite like the previous case in which it said unable to find image, because back then I didn't have the image on my PC. This is because Docker stores the images in a local cache, so that if in the future we have to reuse the image, we don't have to download it again just to run a container from it. We can visualize all of our images by writing docker images. If I want to filter my images, in the case that I have too many images, I can say -f reference, and let's say that I want every single image that starts with hello. So I can say hello asterisk, enter, and as you can see, we have hello world, which is our image. We have the latest version. This is its image ID. It was created 11 months ago, and this is the size of the image. Now we saw the images, but what about the containers? We would like to see what containers do we have on our machine running. So for that we can say docker ps. And as you can see, we don't have any containers. But why is that? If we just run two containers. The reason for this is that this image, hello world, is a really simple image that only displays hello world in the console, and then the container exits after it has finished its task. Other containers, like containers for web applications, tend to hang around indefinitely until we stop the container. If we want to see all the containers, including those that have been stopped, we can say docker ps-a, and as you can see, we have several hello world containers, but the two that we are interested in are these two, because these are the most recently created containers that we have. And as you can see, it says that they were exited about 3 minutes ago. Now, what if we don't want these containers laying around here? We can remove them, of course. We can say docker rm, and we can make a reference to this container. For example, we can use the 3 first characters of the container ID. So I can say 924, and then this container was removed. I can see that by making ps-a again, and as you can see, we don't have the 924 container listed here because we just removed it. We can also remove several containers by listing their respective IDs. We can say 640.181, CC6, enter, and as you can see, we deleted 3 more containers. Now, what if we don't want to do this manually? What if we want to just run the container, and when it exits, we want the container to be removed? We can do that from the get-go by saying docker run --rm, which means remove hello world. But before that, let's remove these 2 final containers, a3d, and now as we were saying, we can say docker run --rm hello world, and we're going to press enter, and as you can see, we have hello from Docker, but if we write docker ps-a, we don't have any containers here because by saying --rm, we're saying that we want to remove the container once the container stops running. Now, of course, it would be really boring to just have containers that display a simple message in the console and then exits. Something else that we can do with containers is to have web applications in them, and then we can access those web applications from our machine. So let's do that. We're going to run a new image that have a Nginx server with a simple HTML file. So we're going to say kitematic/hello world Nginx, and we're going to press enter, and as you can see, we have some logs from the container that says that the worker has started, so we are serving a web application from our container. Now, sadly, if you go to Google Chrome and you say something like localhost 80 or whatever port you think the application is in, we're going to see that in my case, because I have IIS, I'm just getting IIS, but this is certainly not the application served by Nginx by default. So why does this happen? This happened because something that we said earlier. We said that containers are isolated and nothing goes in or goes out of a container unless we explicitly configure it so that we can access the container from outside of it. So what we want to do is to make a mapping of a port in the container to a port in our machine. For that, we can use a-p or publish option when we're running the container. So for that, we're going to go back here and we're going to press Ctrl+C to exit the container. Let's make docker ps, and as you can see, we have the container running. We can remove it if we want by saying docker rm e81, and because the container is still running, because as you can see it has the status up, we need to force it so that it can be removed. Of course, something else that you could do is to stop it first, but in our case, this is good enough. Now what we want to do is to say docker run, we're going to say detach. Detach, what it's going to do is that it is not going to enter to the container just like we did here. What we're going to do is that we're going to run the container, but we will be able to keep writing commands on our PowerShell instance. And after that, we're going to say publish. With publish, we can map a port from our machine to a port of the container. So we can say something like 8011 maps to the port 80 inside of the container. So the first port is the one from our computer and the second port is the one from the container. So we're mapping from our computer the port 8011 to the port 80 of the container. Of which container? Well, of the container that results from running the image kitematic/hello world Nginx. And we're going to press enter, and as you can see, we're not having displayed these logs that we had here because we're running in detach mode. so that we are not entering into the container immediately after running it. What we are getting here is the ID of the container. And of course we can say docker ps to see that our container is indeed running. But now, if we go to localhost port 8011, if we go here and we say 8011, we can see that we have this page here, which means that we are accessing the internals of our container from our computer. Now, this is not the only way to interact with the internals of a container. We can actually go into the container from our PowerShell instance and navigate the files of the container, because as we said before, a container is like a computer, and that computer we can access it from our command line. So let's do that. Let's come here and we're going to use the options interactive and TTY. Interactive, as its name implies, allows me to interact with the internals of the container, and TTY allows me to run commands on the container. So what we're going to do is that we're going to say docker exec, because we want to execute a command in a container, and we want to say interactive and TTY so that we can get into the container. Which container? This container that we have here, DAF, and we're going to say bin shell. And now we are inside of the container. If we say ls, we have the directory of the container. You can see that we have a index.html file. So if I say cat index.html, we're going to have the internals of that file. As you can see, we have to edit files, double click the website files, which is the same message that we have here, to edit files, double click the website files. So definitely we are inside of our container. Now, we're not limited to just going into the container and reading from it. We can extract information from the container, we can extract files from the container, and we can put other files into the container, which means that we can edit a container. We said before that images are read-only, but this does not apply to containers. Containers are editable. So let's do the following. What we want to do is that we want to extract this index.html file that we have here. So for that we have to exit our container. So let's write exit here, and now we are back to our PowerShell instance. And now what we can do is to use the cp option to copy files from and to the container. If you need help with this or any other command, you can use --help. For example, we can say docker container cp --help, and we're going to get some help in how to use this command. In our case, what we want to do is to take this index.html to the current directory in which we are in our computer. So what I'm going to do is that I'm going to say docker container cp, and we want to copy from the container to our computer. So we're going to say the container, the identifier of the container, which is DAF, and we want to copy index.html, and the destination is going to be index.html on our computer. Now if I go to this directory, I will find an index.html file, which is this file that we have here. As you can see, it says to edit files, double click the website files, which is the file that Nginx is serving. Now we can edit this file. We can say something like edited from VS Code, and we can save this file, and then we can go back to Windows PowerShell, and now we're going to repeat the same command, but we will do it backwards. We have to exchange destination and origin, so we're going to do the following. We're going to say index.html here, so that we're copying from our current directory the index.html file into the container. So now let's press enter, and because the way this container is built, we have to do the same also for the website files, which is where the index.html that is being served by Nginx is located. So I am going to say website files here. Let's press enter. And now if I go to Google Chrome and I refresh the page, we are going to see that we have edited from VS Code. So we are actually editing our container, and we can see that change reflected here. Now, there is one bit of a problem. Let's do the following. Let's go back here, and let's say that I want to run another instance of my web page. I want to say docker run, or we can just find the command here. We want to run the same Kitematic Hello World engines, but now we want to have another instance that is going to be on port 8012 on our machine. So let's press enter, and it is running. So let's go here. I will duplicate this, but I will go to 8012. But as you can see, we don't have the message edited from VS Code. We have it here, but we don't have it here. Why is that? Well, again, we can't edit images. We only can edit containers. So what we did here was to edit this particular container. We edited the DAF container, but this new container that comes from the original image does not have this change that we did here. So what can we do in this case? Well, we can create a new image. Of course, we are allowed to create images for ourselves. So let's do that. What we are going to do in this case is that we are going to create an image from this container that we are serving this file from. So let's go back to PowerShell and let's create a new image from the modification that we did to the container. So what we are going to do is that we are going to use the commit command. The commit command creates an image from a container. So let's say docker commit, and we want to use that DAF container, which is the container in which we modified the index.html file. So docker commit DAF, and we have to give the image a name. We can name it new engines, and we can press enter. And now if we say docker images -f reference new, and as you can see, we have new engines, which is the image that we just created. Now we can run that image. We can say this docker run detach, and you don't have to write detach if you don't want to. You can write -d and -p. These are shorthands for detach and publish respectively, and we can say 8013. But we cannot run this image that we have here because this one have the original index.html. What we want to run is our new image, new engines, and we can press enter. And now we can go back to Google Chrome. I can duplicate this and I can say 8013. And as you can see, we have edited from VS Code, just like we had here, which means that we actually created a new image from our modified container. Now, there are better ways to create images. In the next video, we're going to study the Docker file to create images. If you like this video, please make sure to subscribe to my channel and let me know what you want me to cover next. Thanks!